listeners, Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India, through its National Council for Science and Technology Communication and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Charvi and post-production by Professor Kaushik P. Kanchan, Krishna Kapil, Malla Tejesh of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Previously on our show, we sat down with Dr. Subash CK, Inspire faculty at the Center for Nano and Soft Matter Sciences in Bengaluru. His work in superhydrophobic coatings and nanomaterials has graced top journals and national conferences. In this episode, we will talk about the competition and more about his research.
I'm as a living example because I started my research career in 2000, around 2008 kind of thing I have when I'm doing my MSc project. So I got I should thank definitely Government of India because I studied everything with the fellowship from the government, and I started my Indian Academy of Science has given my fellowship. First nanomaterial synthesis was done from IAC only. This under a fellowship. So then I started my after PG I have done my doctoral studies with the fellowship only. So the support is enormous, and for research what I would suggest when I after PhD when I started my postdoctoral experience, and this DST Inspire fellowship itself is a very prestigious fellowship in India, so that they have provided for this particular work that you have to note, because this work is having that much technological aspects. So because we are not only stopping on the material characterization or basic study, we are really converting into engineering technological aspects. So government is now focusing on prototyping, you know that, right? Government always thinking about now prototyping, and not only on materials, basic science. Basic science is obviously required because that is the core of any research. Basic science is required, then we are converting into a prototype, then that level will be increasing actually. And then if you can think about some kind of a startup, so obviously government is supporting now startups and all. One of my student itself is thinking about something like that actually. So my senior most student is thinking about making some kind of devices, integrated kind of devices which can be useful for producing more energy from mechanical energy conversion actually. And this pressure sensing aspect also, we are already trying some pressure sensing aspect because sensing will be more easy for laboratory scale. So because I already told the power output we are getting is bit low, but we are trying to enhance that. Then after enhancing only we can use it as a industrial kind of product. So obviously we are in discussion with some industries as well. When I started in 2008 or 2009, that time in India only 1 or 2 labs are looking into this kind of research. Now a lot of others are also, obviously I think from here itself some of them are working on piezoelectricity. So I started in 2008, 2009, that time no one was working in, at least in the southern part of India. So some groups are working in IIT Kharagpur and all. But now everybody in all material they are looking for this kind of application, this kind of properties actually. So piezoelectricity and triboelectricity, because all are looking for renewable energy, because always we need that energy aspect into really good. And hydrogen is another aspect actually, but obviously hydrogen will come into place, but then the problem is when hydrogen energy comes into picture, the storage and transport, those kind of aspects will come into a big trouble set actually. So, but for this kind of mechanical energy to electrical energy, no such kind of limitations. It's a really versatile kind of technology. That is the advantage actually. So, yeah.
And these technologies.
Yeah, so I already mentioned in Western countries already they are acquired this technology, but they are using different type of materials. As I told, some research gaps are there, still there. That's why India is really looking into those kind of aspects. Indian researchers are really looking into those aspects, and obviously within 10 years kind of time we can able to solve those kind of stability aspects, this lead freeness, environmental friendliness, and the power issues. Those kind of things we really looking into utilizing and optimizing different kind of materials and different kind of systems actually, because since we are working on a mechanical to electrical energy aspect, so the system should be really flexible. Otherwise, it will easily break down. And if you are only using ceramic material, that's a major problem. So it will break down with one or two steps or whatever it may be. And if you are running through a floor which is powered with this piezoelectric material, it should not break, right? So for that, flexibility aspect has to be improved. So for that only we are trying to put it in polymer aspect. Obviously temperature will be an issue over there, but still if you really optimize this polymer nano composite into onboard for this piezoelectric application, then it will help us. That's what. So within 10 to 15 years, it will be in market. That's what. Yeah. That's what. See. This kind of things obviously coming as an energy aspect, obviously it is a large scale actually, but if you are considering a particular personal kind of, so we are working on wearable devices actually. So if you can able to find out some, see if you can wear it on your this one wrist and you can monitor your heartbeat in that way, those kind of things can be done, really monitor your health related aspects, and those kind of sensors also we are bringing into on board. So piezoelectricity will convert. Recently we have done a work like the pattern monitoring of your this one. So if you bend your finger like this, it will monitor. So if you put your sensor over here, if you are bending your finger like this, it will monitor that signal. So we are generating one voltage pulse. So biomedical aspects can be brought into picture, as well as another point is we recently, so it is under consideration actually, we recently made a device which can really monitor a patient. Okay, so really monitor in the sense we can put if a patient is paralyzed, so if you can put your sensors on his finger, so some movement if it is coming, suddenly we can get it through wireless message or something like that. Those kind of things are coming out, and we are really working on another aspect. This is already there in some of the groups are already tried this one, but we are using it with some different material and different sensitivity. Those kind of aspects we are bringing into picture. Here what we are trying to do is you know about sign language, right? We are doing so whoever can't able to talk, so speak, so they are using the sign language. So we are developing a gloves which can predict the sign language. So with this piece of electricity, so sensors can be put into picture. So in the large area, the large aspect, we are definitely thinking about energy, and in the individual or a particular man-to-man point of view, we are bringing about the sensor aspect as well. So with placing the sensors on different fingers, we can monitor the finger movement that I already told, and with this finger movement we can understand the this one sign language as well. So Indian sign language is bit complicated, but American sign languages are having alphabets. We can easily decode those alphabets. That's the beauty of that work actually. Yeah.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी